Good day. We are looking at our next lesson, lesson 3, which is 11.6 in the textbook, volumes of pyramids. So before we begin, I want to just kind of touch on the height of a pyramid. And cones will use the same philosophy. There's actually two types of quote-unquote heights inside of a pyramid. First off, you have what we refer to as the slant height. So as we have our pyramid, we have our slanted side going up, all right, as you can see. The height that runs from the base to the point along the slanted side of a pyramid is referred to as the slant height. That is different than the quote-unquote height, or true form would be the altitude of the pyramid. That's going to be the segment that runs from the point where all the sides meet perpendicular to the base. That is the true height of the pyramid, or what we refer to as the altitude of the pyramid. So when we look at the formulas, and again, these are the same formulas we looked at previously, when we looked at our formulas for the prism and the cylinder. When we look at the formula for the pyramid, it's capital V equals 1/3 capital B little h. Again, capital B is going to be the area of the base. If it's a triangle, it would be the area of a triangle. It could be a rectangle, a square, hexagon, you name it, area of the base. And again, this h, the height that we have here in the formula, that is specifically going to be essentially the altitude of the pyramid, that segment that runs from the vertex point at the very top perpendicular to the base. So we're going to look at a couple different examples. I specifically chose these two so that we could see the different bases and how this would work. You're going to find it's very similar to what we did when we did the prisms. So let's see here. First off, as you can see in our first example, we have a triangular pyramid. So again, our formula is volume equals 1/3 capital B, which is the area of the base, times the height. So again, because my base happens to be a triangle, I have to find the area of the base. So how do we find the area of the base? 1/2 base times height. So my two terms are 4 and 6. So we end up with an area of the base of 12 square meters. So when I go to my volume formula, I can replace the area of the base, capital B, with that 12. And now I want the 9. And again, that's going from the point perpendicular to the base, which in this problem is 9. So we get a total of 36 cubic meters. Now on our second question, here we're looking at a square base. So when I find the area of the base, I'm doing it for a square, so it's side squared. So we end up with 10 squared, or 100 square centimeters. Again, we replace our capital B, area of the base, with that 100. And again, height from point perpendicular to base. So in this problem, it's going to be 12. So we end up with a total of 400 cubic centimeters. So now let's work backwards. What if they gave us the volume and our task was to determine what the height was? So in this example, they give us a volume of 24 cubic meters. We've got a triangular base. We do not know the height. We don't know the altitude. So again, we're going to start out by finding the area of our base, which happened to be a triangle. So I do 1/2 base times height, and we end up with 9 square meters. So then we go to our volume formula, and we're replacing the capital B with that 9. But this time we don't know the h. That's our unknown. I do know the volume is 24. So I'm replacing V with 24. H is going to be the variable I solve for. So we do a little simplifying. 1/3 of 9 is 3, so we get 24 equals 3h. So h is 8, or 8 meters. The last thing we're going to look at is how do you find the volume of a composite figure? Like we looked at in our previous section, we're going to have to do the volumes of the shapes and add them together. So here I happen to have a cube and a pyramid. So if I take the volume of the cube and add to it the volume of the pyramid, it's going to give me my total volume. So let's see here. Here's our work. So I'm going to start out by finding the volume of my cube. Length of each side is the same, 6 by 6 by 6. So we end up with 216 cubic meters. Now my pyramid, we're going to do the area of the base, capital B. Again, it's a square, so we get 36 square meters. We take and replace capital B with 36, and the height from that vertex point perpendicular to the base is 6, for a grand total of 72 cubic meters. So when I add the two together, my total volume ends up being 288 cubic meters.